Okay, today in lesson 3, we're going to solve some right angle triangle problems that involve angles of elevation and depression. But before we get to that, we need to review some important basic angle theorems. You would have learned these in grade 9, used them a bit in grade 10. Let's review some important ones. First of all, the interior angle sum. Interior, I'm just going to make a little note here and you can write stuff down yourself. Interior angle sum. All right, well, what's that? That says the angles inside any triangle will add to 180 degrees. So these three angles will always add to 180. So for us, even a right angle triangle, right? These three corners will add to 180. So if this is 90, the other two would have to also add to make 90 to make 180. The next one is for quadrilateral. So any four-sided shape, like a rectangle, square, or anything with four sides, the four angles have to add to make 360 degrees. All right, so it doesn't matter what it looks like. It could be the wackiest looking four angle shape. It's kind of a trapezoid. These four angles will always add to make 360. All right, next angle theorem that we got to remember, and that'll come in handy over the next few lessons, is the opposite angle theorem. All right, so what's that? The opposite angle theorem just says that if you have two lines intersecting, the opposite angles will be the same. So whatever this angle is here, it'll be the same as that. So if this is 30, that's 30. And whatever this is, that'll be the same. So if that was 150, the other side would be 150. And obviously all four of these angles would have to add to make 360 because they make a full circle. Three more that are very useful are for parallel lines only. So these last couple are for parallel. Did I spell that right? Oh well. Lines. I can never remember how many R's are in it. All right. So first one is called alternate angles. It's probably the most popular one and the one you'll use the most. Alternate angles. I'll just write alternate angles here. Okay. That is better known as the Z pattern. So if this line and this line are parallel, okay, and again, these lines could go on forever like that, right? But we have a Z pattern. These two angles will be the same. So again, let me just highlight the Z. Okay, so if we have a line intersecting them, the two angles will be the same. The next one is called corresponding angles. Corresponding, I know that one has two R's. Angles, at least I think. Same thing. What if I have a line and a line? This you'd know better as the F pattern. So that says any two angles here and here will always be the same. So it makes the pattern of an F. So a lot of times the Z pattern and the F pattern overlap each other. You might notice where you can use one, you could use the other. The final one that will be very useful for some of today's questions are co-interior angles. And that is better known as the C pattern. All right, so let's say we have two parallel lines. Oh yeah, and the last one would have to be parallel. That's what these little arrows mean that I'm drawing. It means that they're parallel. All right, so let's say I have another line that intersects them. And again, these can all overlap one another. Well, the C pattern says if I draw a C with these angles, these two corners, this one and this one, these two angles have to add to equal 180. So if this is 30, this would have to be 150. So those two angles have to add to make 180 degrees. Okay, so keep these in mind as we go through the lessons, as they'll be really useful to solve some questions. They can make shortcuts at them. Sometimes when you're stuck, notice there parallel lines and you can usually find missing angles. Okay, so first let's talk about angles of elevation and angles of depression. So angles of elevation and depression are just angles looking up or looking down. But problem is people always draw the angle of depression generally in the wrong spot. The angle of elevation is pretty easy to spot. You got a horizontal line. If you look up, the angle of elevation is what you get from looking up. The angle of depression, though, is where people always draw in the wrong spot. Because let's say I draw a right angle triangle here. And a lot of people put the angle of depression here, but that's incorrect. The angle of depression is if you look out straight. So from this airplane, if I look out straight and then look down, that's the angle of depression. So be really careful because this is not where it goes. And that's usually where people put it if they make a mistake. It's right here looking down from a horizontal line, or, and again, the angle of elevation looking up from a horizontal line. So let's look at a couple quick examples here. This is a classic example, just a basic one. You got two buildings, they're 100 meters apart. So first thing I can draw on is there's 100 meters right there. They're 100 meters apart. All right, and obviously we're gonna have a triangle here. So you know what? I'm gonna draw that in right there, and there's my 100 meters. And I can make this a right angle triangle. All right, so a surveyor stands at point A, right up here, and measures the angle of depression to the other building to be 35 point, now what the heck is this? That 26 shouldn't be there. There we go, 35 degrees. All right, so he looks down at an angle of 35 degrees. Angle of depression, I have to draw in this horizontal line. The angle of depression is not right here. Again, that's where people always draw it in. It's in the wrong spot. The angle of depression is you draw a horizontal line if you look out straight, and then if you look down, it is 35 degrees. Oops. All right, so that's where our angle of depression is. Now, remember our Z pattern we just talked about a little while ago? That Z pattern says, hey, if I know this angle, I know that angle, and these, I'm sorry, if these are parallel lines, then these two angles are the same. So if this is 35 here, I can also say that this corner here is 35. So basically we did that, so now we have our right angle triangle. We have one side, we have the angle. Let's see what else they're giving us here. The taller building is 140 meters. Okay, how high is the shorter building? So why don't we just solve for, I'm going to label it here with an X. Why don't we solve for this, and then we can just subtract that from the height of the taller building to find the height of smaller building. So we're looking for that right there. Okay, so I'm going to take my triangle out here. Let me get rid of the Z. And I'm just going to draw it separately so I can really see what I'm doing here. So here's my triangle. All right, not the best, but there's X, there's 100, there's 35. All right, so we got to figure out using SOHCAHTOA, or if you like to use X cos theta, or sorry, R cos theta or R sine theta, you can use that too, whatever way you like to set it up, but make sure you show me in your homework how you set it up. So I'm going to say this is my hypotenuse, this is the adjacent side to my angle, and this is the opposite side. So what we have is we have the adjacent, we obviously have the angle, and we're looking for the opposite. So we need the trig function that uses opposite and adjacent. So, you know, there's SOHCAHTOA. So again, what's the point of SOHCAHTOA? Just a quick way of remembering which goes where. So we're looking for opposite. We don't have the hypotenuse, so we can't use that. We have the adjacent, and we're looking for the opposite, so we're not going to use that. Looks like we're going to use tan because we are looking for the opposite. We have the adjacent, so yes, we're going to use tan because our question involves the opposite and the adjacent. All right, so let's set it up. Tan of an angle is opposite over adjacent. So set up your expression for me. Then sub in what we know. Tan of 35 degrees is opposite, which we're just going to call X, over 100. So we're going to multiply both sides by 100. 100 times tan of 35 degrees. And let's punch in our calculator and see what we get here. So let me clear out from last time. All right, so I'm going to go 35. I'm going to do the tan first. And again, your calculator, you probably hit tan and then 35. Make sure you're set to degrees. Everything in this unit we're doing is with degrees. Times it by 100. If your calculator's on radians, you're going to get wrong answer every time. It looks like we're going to round everything to one decimal, so about 70.0. Approximately 70.0 meters. Now, remember, that's the height of X. That's this height right over here. That's this, right? That's 70.0. So to find the height of the building, again, this is not drawn accurately. I shouldn't say again, I haven't said that yet, but these are not drawn accurately. But we're going to find this height here because that's the height of this building. So all we got to do is just take the height of the big building, 140, subtract the height of X, which is 70, and we get out approximately 70 again. So that's our answer. About 70.0 meters is the height of the smaller building. 70, right? Because this side over here would also be about 70 because X is 70. All right, let's take a look at another example. Okay, here we go with example 2. Louise is standing 200 meters away from a tree. All right, so here's Louise. I'm going to do some pretty bad drawings. And, I probably should use my line tool because that's not a great line. Let's see here. Well, I've lost it. There it is. Okay. There's the ground. And here's my tree. Beautiful tree. There we go. Okay, so there's the tree. I'll just label it tree. There's the ground. All right, and she's standing 200 meters away. All right, she measures the angle of elevation to the top of the tree with an inclinometer, which is just a way of measuring angles. And she determines it to be 17 degrees. Assuming she's 1.6 meters tall, how tall is the tree? So to be clear, I guess what they're trying to get in this question is she's measuring, I know it doesn't make sense, from the top of her head. They're basically saying she's measuring from here. She's holding it, is maybe what the question should say, at the top of her head, holding it above her. So she's 1.6 meters. Now, all that's really going to do is at the end, we'll just have to subtract her height. So let's just say this is actually our triangle from here. All right, so here's our triangle from the top of her head, and here we go. Now, where's the 17 degrees go? That is the angle of elevation. This is an angle of elevation question. There we go, elevation. So looking horizontally and then looking up, that's where the 17 degrees would be. And this is 200 meters long. So all we need to do is solve for this length right here. And I'll just call this length x. All right, so we got our triangle. Let's label our sides. So this would be my hypotenuse, obviously, the longest side across a 90-degree angle. This would be the adjacent, the side next to the angle that we're given. And this would be the opposite. So we're looking to use sine, cos, or tan. Well, we have the adjacent, and we're looking for the opposite. So if you look back at SOHCAHTOA, that would be tan, TOA. Because we have opposite or looking for opposite, and we have adjacent. So we're going to use tan. So tan is pretty common in a lot of questions. You'll find a lot of word problems, sometimes more than sine and cos. Tan of an angle is opposite over adjacent. So let's sub in what we know. We know the angle is 17 degrees. The opposite we're just going to call x, and the adjacent we're going to call 200. All right, so we're just going to go, what's 200 times tan of 17? Very similar question to our last problem. All right, so let's get out our calculator. Let's figure that out. So I'm going to go clear everything out. Okay, 17. I'm going to do tan of 17 first. Again, your calculator, you're going to do tan of 17. I'm hitting 17 tan, and I'm going to times that by 200. And I got 61.14. So I'm just going to round that to approximately 61.1. Meters. Now, the only thing missing from the question is this piece right here, which is the height of Louise, 1.6. So the tree, we're just missing that extra little bit of height there. So all we got to do is just add 1.6 to that question, and we're good. So 61.1 meters plus 1.6 meters is approximately, the height is approximately 62.7 meters. So it was a pretty simple question. It's just, this is a really common one you'll see where they give you, someone's measuring from the top of their head, and you just draw the triangle from that spot, and we just add their height at the end. Let's look at one final question. Okay, our next and final example is a little bit of a trickier one, and you got to draw yourself a half decent diagram to understand this one. So we got a pilot up in the air. So here's my airplane. It's going to be a real beauty. There it is, just gorgeous, flying through the air. Okay, so a pilot maintains an altitude of 30,000 feet over level ground. So that means that's how far up he is in the sky. So here we go. I'm not trying to make this too big, so I got some room to do some work. Okay, so the pilot, all right, it's not perfectly vertical, but you get the point, is 30,000 feet in the air. All right, so let's draw the ground. Here's the ground. Not really attaching up well. There we go. All right. Pilot maintains an altitude of 30,000 feet over level ground. The pilot observes the airport at an angle of depression of 15 degrees. So why don't we just say this is the airport over here at the end. Airport. All right, so he looks down. Now, again, remember with angle of elevation questions, I'm going to make this into a rectangle. In fact, I should have just drawn a rectangle from the start. But we will just draw it like that. Okay, so if he looks down at the airport, the angle of depression is here from the horizontal looking down. Again, where does everyone draw it? They always draw it here, and that is not where it goes. All right, so you have to draw a horizontal line and then look down. So he looks down 15 degrees. All right, if the airplane continues 16 more miles, so if he keeps flying this way, flying, wherever, we'll just say here is 16 miles. Okay, what will the new angle of depression to the airport be? All right, so he looks down again at the airport from here. This is what we want to find. So I'm just going to call this alpha. We'll just use a little fish. All right, so that's what we're looking for. What's the new one going to be? All right, so to do that, what we're going to do, first, why don't we convert? We got one of our units is in miles, the other one's in feet. So I'm just going to convert 16 miles first of all. Come down here and just do a little bit of work. 16 miles. If I times it, it says there in the hint, 1 mile is 5,280 feet. So let's times that by 5,280. You know, the calculator, 16 times 5,280, 84,480 feet. All right, so we're going to do everything in feet. What did I say, 8,400? All right, there we go. All right, so that's how many feet it is. or we can just put a little dash next to it, means feet. All right, so I'm going to write that up here. That's this distance right here. That's how far he traveled, right? 16 miles or 8,480 feet. All right. Okay, now here's the whole trick to the problem. How are we going to solve this? Now, don't forget, these are right angles. All these corners are right angles. This is a right angle. This is a right angle. The other two corners are right angles. Why don't we start by solving for this length here? I'm just going to call this x, this length across here. All right, from there to there. So now, what triangle am I going to use for that? Let me highlight the triangle I'm going to look at. I'm going to use this triangle right here to solve for x. So see that triangle I'm highlighting? Now, here's the deal. I need another angle. I need an angle inside this triangle. So using the z rule, if this angle up here is 15 degrees, this angle right here would be also 15 degrees. Another thing you could do, some of you might have also made this as a 90-degree corner, so 90 minus 15, right, would give you 75 degrees. So you can work with either corner. I'm just going to work with that 15-degree corner in the bottom. So the neat thing about angle of elevation depression, they should be the same. If someone looks down at you at an angle of 15 degrees from the airplane to the airport, someone at the airport should be looking up at an angle of elevation of 15 degrees. So let's solve that triangle right there that I highlighted. All right, so what do we have? Let me just draw that triangle kind of on its own separately. We have, this is 15, so this is 30,000, and this is x. So if we label this thing, we don't have the hypotenuse, we just have the adjacent and the opposite. So that calls for tan. Tan is opposite over adjacent. So let's sub in what we know. We know the angle's 15 degrees. We know the opposite, oops, it's 30,000. I wrote 3,000 there, 30,000. And the adjacent we're going to call x. All right, so let's multiply both sides by x, which moves the x to the top on the other side. Divide both sides by tan of 15, which is just going to move that to the bottom. And let's punch that into our calculator. Okay, so I'm going to start with 30,000 divided by tan of 15. Again, I have to hit the 15 first, then tan. Most calculators you hit tan of 15 and equals. And I got a pretty big number, 11,961.52. All right, let me write some of that down. 11,000, what is it? I got a noisy keyboard. All right, 11,961.5. All right, there we go. Okay, so that's the length of x. Now, what we could do is to find this length right here, right? All we got to do is take x and subtract the 84,480 feet. So to find this length, let's just take the whole length across, which is x. So take that 111,961.5, and let's subtract 84,480. I already got that number in my calculator, so let's take that and just subtract 84,480. All right, now we have the length of that part I highlighted right there in blue. All right, so that's approximately 27,481.5 feet. All right, so that's that length right there. Let me just write that in here, 481.5. Sorry, every time I draw a 4, it seems to connect and make it look like a 9. All right, so now to finish it off, we're just going to do another right angle triangle. We have a right angle triangle right here. All right, so we know this side, the 24,000 or 27,000 we just found. Don't forget, we already know this side is also 30,000 because it's the same height as on the other side over here, right? These are the same. So that's 30,000, that's 30,000. So all we got to do here is just another right angle triangle really quickly. All right, so let's just do one more right angle triangle for this green triangle here. All right, so once again, we're going to use tan because if you look at this triangle, if I draw it out, if I pull this triangle out, right, this would be, or let's just label it right here, right? This is our angle. This would be the adjacent side of that angle. This would be the opposite. So when we have adjacent and opposite, we use tan. So tan of an angle is opposite over adjacent. So we are trying to find the angle. So in this case, I'm just going to use alpha for my angle. Opposite doesn't really matter what symbol you used. I just used the alpha there to distinguish from the other angles, but it doesn't really matter. 30,000 divided by 27,481.5. All right, and then we're going to take the tan inverse of that. And that'll give us our final answer. So this question seems a lot harder than it is, and you're going to have one just like this in your homework. So just follow the same method that I did. I just want to see if you can kind of follow the same pattern. It's just solving two triangles. Both of them we use tan with. So let's finish it off here, get our calculator back up here. Hit clear. All right, 30,000 divided by 2,7,481.5 equals, and let's do the tan inverse of that. Second tan. All right, 47.5 degrees approximately. 47.5 degrees. That's the final answer. So if the pilot moves closer and looks down, that is the angle of depression that he or she would look down at. All right, so that's the final example for lesson 3. Give the homework questions a try and submit them when you're all done.